Good afternoon and welcome to the HDIAC webinar series. This is our last webinar of 2015, and today we have a critical infrastructure protection webinar presented by Benjamin Riddell from Arizona State University. Thank you, Benjamin.
Hi, thanks everybody for joining us. I'm Ben Ruddle. I'm on the engineering faculty at ASU, and thank you to Melissa and HDIAC for hosting this webinar. What I want to talk to you today about is a new data set, a new capability that's emerging around mapping our vulnerability and indirect security risks to drought in the global hydro economy. So that's our topic, and you'll see what I mean in a moment. So there's been a lot of talk in the news and in the security community about drought, about water scarcity, and about how this might affect us in an increasingly globalized and water-scarce 21st century. Climate change has been discussed a lot, and for good cause. It's presenting us with a lot of challenges in addition to the others that we face in the security community. Not least among those challenges, and perhaps the most severe of all of them related to climate change, is drought. And I'm talking specifically about how drought can cause water shortages unexpectedly, or perhaps with some anticipation beforehand, and how that drought can impact the global economy and therefore the security situation. So, for example, in the United States, what you see here in front of you is a map of our water scarcity. This is a simple water stress index. It's just the ratio of our rainfall and renewable water flow in every county of the United States related to our water use by the human economy. So let me translate that for you. If this map is red, it means that people are using nearly all or even more water than is available on a renewable basis. And that means that we are exposed to both short-term unexpected water shocks, which could damage the economy and affect our supply chain, but it also means that we're affected by increasing long-term chronic water scarcity. And a few things happen when we have water stress. Costs increase, so your costs for managing those water resources start rising. They can rise exponentially. They can go up really quickly as you start to transition to more and more energy intensive and technologically intensive management technologies like water recycling or desalination, for example. Perhaps the more severe issue is that there's a lot of inequity in water scarcity. So if water supplies get cut off, we start falling back on who has the ability either legally or physically to force the water to come to them, and you have winners and losers, and that creates a lot of conflict. And so in the United States, that might mean we have costs, we have political battles, and a lot of uncertainty in that water supply chain. In other countries, it might mean that there is a potential for armed conflict, for famine, and for some of the other things that we worry about. So anyway, water scarcity is a serious challenge, and I think we're concerned especially about short-term unexpected shocks like drought, and that is proportionate to our renewable surface water availability. Groundwater and chronic stress is a different issue because you can see that problem coming for a long way away. That, for example, would be the California groundwater management problem currently. We've known about that for 50 years, so it's not really a surprise. It's sort of a different issue. So let's talk about how these new data sets can tell us about our vulnerability to drought through teleconnections. So global and regional trade have both grown dramatically since the 1980s. This map you see in front of you is from a 2012 paper in PNAS, which maps virtual water flow. So virtual water flow is just a map of our water supply chain. And this map was done at the level of continents. So we're looking at primarily waterborne international trade. In goods and services, that were produced using water. So this flow has created a net dependency, for example, of the world on North America and South America, which are these major global exporters of water-derived goods and services. But you also have a lot of flows within the continents, of course, and what this map doesn't show you is that most of the trade is local and regional. These trades are teleconnections, and teleconnection is a pretty simple concept. It's basically what it sounds like. You're creating a dependency or a connection between two spatially distant locations. And so when we have trade, that creates a teleconnection by default. What's special about a virtual water teleconnection is that it is the special case where trade depends on water resources in the originating location. And so the trade is rendered proportionate to that dependency. So the right tool for understanding a remote connection in the economy and a remote vulnerability to water resources and to drought in a distant location is virtual water flow. And that's why this concept is important. A new development is that we are just now in 2015 beginning to understand the detailed virtual water teleconnections in the global economy. This is really important because, as I mentioned in the last slide, very much a very large fraction of these virtual water connections are within regions, and they are within local areas. A lot of them connect regions to cities, and that's a typical pattern. So the vast majority of these connections are not international in nature, although those are also important. The big story is really at the regional and local scale and at the river basin scale. And that's the other reason why these new detailed data products are really important. It's because water resources are not a continental scale or national scale issue. Water resources are much more local. So as we'll see in a moment, it matters very much whether a drought or a water shortage impacts on one side or the other of a river basin boundary. It matters very much which side of a political boundary it hits you on, which city is affected. And so we need to get down to very fine scales in space and also in time to understand the impacts that are going to occur here. Also, as we know from the last decade, unfortunately, you know from examples in Somalia and now in Syria and elsewhere that these drought-influenced conflicts are often low-level conflicts. They're often local and regional conflicts, not global conflicts. So we really need this very precise, detailed local information. So we are the first country, the United States, to have this data product available. The National Water Economy Project has just produced a new data set. It's the National Water Economy Database, NWED, for the United States. And this is the first really spatially detailed and economically detailed database of these virtual water teleconnections in the economy. So this gives us a map within the United States of where our vulnerabilities are through those teleconnections. And it's the basis of all kinds of interesting math that it is very interesting, I think, for the security community. This is just a brand new capability that's emerging. It's new to science. And I wanted to emphasize that because that's why you perhaps haven't seen this before. This is really hot off the press. So I'll ask you a question first. We're getting into the substance of the talk now. So do you know where in the United States a drought would hit us hardest? In other words, where are we vulnerable to drought in the United States? That is now a question that we can answer for the very first time because of this data set. There's a paper in review right now. It'll be coming out in the spring that maps some of this stuff. So this is a map of that vulnerability, and this is the product of your virtual water use. That's virtual water inflow to a county, multiplied by the water stress factor of the originating location. So as you can see, it's primarily the western United States that is vulnerable. And these are the places we need to worry about drought happening. These are the locations where there is a lot of vulnerability. So we are very vulnerable to droughts that are going to occur in southern Arizona, in California, southern Idaho, and throughout the western U.S. generally. But also, surprisingly, you see some issues showing up in South Texas, Mississippi River Basin, Chicago, and southern Florida. So these are also places where we might need to be investing in water security and national water infrastructure to help secure the situation. On the flip side, if you're green on this map, you don't have a lot to worry about. So these would be lower priority locations. We can get into even more detail too. So I can put a pin on the map. I can put that pin in there in a specific city or a specific community, and I can ask the question of where's this water footprint, or where is the virtual water sourced from for this specific community. This is really important because we want to manage the vulnerability and the resilience of a community to water stress and to water shocks. It's a function both of their direct water infrastructure, so that's the pipes that go out to their local rivers and aquifers, and how well that system works, but it's also a function of this virtual water map, this virtual water footprint on the landscape. And the question is, where is this city's water supply chain located, and is that a secure water supply chain? So we can do some math on that now. We have some papers out which show how you can actually calculate in a formal way vulnerability and resilience of a city or any location to drought as a function both of its hard local infrastructure and of its water supply chain. So about 80% of this city's water footprint, and therefore vulnerability, is actually in its water supply chain. It's not local in the city of Flagstaff. It's this water supply chain that's sprawled across the western U.S. So this map that you see is a product, again, of the water stress and the virtual water outflows to Flagstaff. And so the places that show up in red on this map are the places that Flagstaff needs to be concerned about. Now, if you were a water manager, an economic manager, or a security manager in Flagstaff, you should be very concerned about droughts that impact southern Arizona. And in fact, Flagstaff is even more vulnerable to southern Arizona and water shocks than it is to water shocks in its own local backyard there in northern Arizona. So Flagstaff is particularly vulnerable to problems in Phoenix. And you see Phoenix and Maricopa County highlighted there in red. So we now have the capability to map these indirect vulnerabilities to drought within the United States. And one of the lessons that comes out of this is that cities and large companies, also security facilities, military bases, they should be managing this water supply chain to shift it, to diversify it, and to spread it around and keep it from being concentrated in these really vulnerable locations. This is another view of that same map. So this is a little bit more focused. I wanted to emphasize the topic that I just brought up in the previous slide. So this is the indirect water scarcity index. So this is the product of virtual water outflow to Flagstaff combined with the water stress. And we can see in a lot more detail here, Flagstaff needs to be concerned about, in general, Nevada, Southern California, Southern Utah, New Mexico, Front Range, Colorado, and a little bit of Kansas and Nebraska. That's where its water supply chain is located. And these are the places where water problems could impact Flagstaff's security. You have a big oil and gas dependency in northwest New Mexico. So if there's water problems that affect the oil and gas sector in New Mexico, that hits Flagstaff. And then if there's water problems that impact the agricultural sector in southern Arizona, that hits Flagstaff. Now here's that formal resilience framework for Flagstaff's water supply chain. This is a paper that we presented in 2015. What we can do is we can map the diversification of this city's water footprint and its water supply chain against several different indicators. So these are indicators on the diversity with respect to politics and governance, the geography of the supply chain, its boundaries. Are you dealing with and sourcing to multiple hydrologic boundaries? Are we sourcing to a diversity of different economic sectors in different locations? So the idea here is that you can translate this NWED information, this hydroeconomic network, into a real concrete metric that can allow us to improve and to manage that water supply chain, to improve security and resilience. This is how we do that. So there's a basket of diversification indicators here which turn into a resilience metric. And when you put this direct and indirect water supply chain vulnerability together with the resilience of the network, you get a diagram that looks like this. And so those vertical and horizontal lines are Flagstaff's local vulnerability and resilience, not including their water supply chain. And then the colored dots are the actual numbers, including the water supply chain and those teleconnections, for every sector of Flagstaff's economy, according to different metrics of resilience. And so what you see there is that on the scale of 0 to 1, with 1 being vulnerable, Flagstaff is sitting at about 0.7 with some scatter, which means that Flagstaff is relatively vulnerable because it tends to have both a local water supply and a water supply chain that are in very water-stressed locations in the Colorado River Basin. That's probably no surprise. But the good news is that on the resilience scale, where 1 is a highly resilient and diversified water supply chain, Flagstaff on average comes out being relatively resilient. So it actually sits at around 0.7 on the resilience scale on average, although different sectors of its economy fare differently. So, for example, we might expect that the agricultural sector and the mining sector in Flagstaff's areas are not so resilient because they're way over on the left side of the scale. That's because they have their supply chains heavily concentrated in one location in Arizona, that is southern Arizona. But on average, Flagstaff, we could say that this place is both relatively vulnerable, but also relatively resilient because it has a really strong and diversified economy and water supply chain. We can do this analysis now for any county, any economic sector in the United States, and we hope to be able to do this for the world, and that's where the real value comes in. So we're working on the United States right now, but we need the community's help to start talking about doing this for the world. And you can, once you measure this vulnerability and resilience, you can manage it. You can use it to predict the impacts of a specific drought. You can ask the question, if there's a drought in Turkmenistan, who is going to be affected by that? Who do we need to worry about being destabilized because of that drought? What sectors of the economy? Where should we be investing our resources, both in terms of water investment and security resources, to try and head off and prevent some of these drought-induced and climate change-induced conflicts? So these types of maps have the potential to anticipate what would happen if drought or climate change impacts hit a certain location, and we can then start to manage and improve the vulnerability and resilience in critical places in the world. You can also identify places you want to avoid. If you're setting up a global security infrastructure, you want to keep your supply chain away from places that are red on these maps. You want to steer your water supply chain away from those spots. So those spots might be places you would otherwise source some of your supply chain, but when you take the water security metrics into account, it turns out to be a bad idea. So what we'd really like to build next is a global product, so NWED for every country and every region in the world. And we think that this would be really valuable for the global security community. It's going to be valuable for USAID and for development purposes in terms of prioritizing investments and resources. And as I said, I think it could be valuable for the security community directly in terms of anticipating water-induced conflict and specifically the indirect impacts of those conflicts, which are generally local and regional in nature. So we have some examples where that would probably have helped us recently. There's been a lot of talk about Syria, and there was a serious regional drought. It didn't necessarily hit Syria so hard, but there were regional drought issues which really affected that rural economy. And I haven't got the results because I don't have the data yet, but I believe that if we did this sort of a math for the Syrian conflict, we would have identified these locations that were impacted by the drought as sources of significant vulnerability in this regional hydroeconomy. So this is something that I think we could have anticipated using this data product. I want to wrap by providing acknowledgement to my partners. There's been a lot of them. Of course, our project is the National Water Economy Project for the United States. We've gotten help from the Great Lakes Protection Fund for regional work by the Great Lakes Commission. Sandia National Laboratories has provided some key data for the United States. The Walton Sustainability Solution Initiatives at ASU has provided some in-kind support. And we have a lot of help from city partners and university partners in our team. I especially want to acknowledge Richard Rushforth, who is a student who's graduating soon from my lab. He has put together the National Water Economy Database itself, and there's a long list of partners who we've been working with on this. So just want to make sure that they get their acknowledgments. It's a team effort on this type of integrative project. So I'm going to wrap now, and thank you very much for your time and attention. Goodbye.
Thank you, Ben. That was a great webinar. It's easy to see where this overlaps with a lot of HDIAC's focus areas. So thank you all for attending, and have a great afternoon.